Hey guys, so welcome to my new video. This video is on multivariable optimization. So this video is a continuation of the series on optimization where I'm discussing chapter number 17 from the book Mathematics for Economic Analysis by sydsaeter and Hammond. So in chapter 17 we are discussing exercise 17.4 and I'm going to start with question 3 now. Earlier I discussed question 2 which had 6 or 7 parts, so you can go and check that video out. If you're new to this channel, I would suggest you to watch my previous videos, otherwise it would be tough for you to understand this. Or if you've read the textbook, then fine, then you can very well just cope up with the stuff that I am going to teach in this class, right? So let's start now. I'm going to solve question number 3 of exercise 17.4. The name of the chapter is Multivariable Optimization by sydsaeter and Hammond, right? So, so question 3 says that determine values of the constants a, b, and c such that fx comma y equals, so there is a function given to us fx comma y, and fx comma y is ax square y plus bxy plus 2xy square plus c. So this is our function. Um, Determine values of the constants a, b, and c. So a, b, and c, a, b, and c are constants, right? Are constants, right? This is c. And we are given that this function has a local minimum at the point 2 by 3 comma 1 by 3 with local minimum value minus 1 by 9, right? So they're saying that this function fx comma y has a local minimum at 2 by 3 comma 1 by 3, right? At 2 by 3 comma 1 by 3. Let me just get out of it. Yes. And this means that and the local minimum value is, and local minimum value is minus 1 by 9. So what does this mean? This means that when we put 2 by 3 comma 1 by 3 in the function, we get minus 1 by 9, where 2 by 3 comma 1 by 3 is the local minimum point and minus 1 by 9 is the local minimum value, right? Now I've explained these concepts, what is local global, in my previous videos, right? So you please check those videos out first and then come to this video, right? Or just read the textbook. The best source to understand anything in today's time is read the textbook, right? And then take the help of GPT or Gemini. Like I try to study in this sort of way, right? So now we need to find the values of A, B, and C. Right. So now we need to find the value of A, B, and C. For local minimum, for local minimum, we need to find the stationary points, right? So for example, 2 by 3 comma 1 by 3 is a interior stationary point, right? Why is it a interior stationary point? Because the condition of local minimum says that a point, a stationary point, an interior stationary point has to fulfill certain conditions, and then we say that it is a local minimum. So if we have a point which is an interior point, interior stationary point, and when we construct a Hessian matrix and the matrix turns out to be a positive definite matrix, then we say that the interior stationary point is a local minimum, right? This means that this point 2 by 3 comma 1 by 3 should be satisfying the conditions of a stationary point, right? So now how do we find the stationary point? By equating the first order partial derivatives to 0, right? So we need to equate fx to 0 and fy to 0. What is fx and fy? I have explained this in my previous videos, but again I am writing. Fx is the partial derivative, the first order partial derivative of the function of x comma y with respect to x. And what is fy? Fy, fy is the first order partial derivative of the function fx comma y with respect to y. And how do we find the partial derivative? By treating the other point as a constant. So if I'm trying to find out the first order partial derivative with respect to x, I'll be treating y as a constant. And if I'm finding the first order partial derivative with respect to y, I'll be treating x as a constant. So now we know that 2 by 3 comma 1 by 3 should be an interior stationary point. This means that when I equate this fx to 0 and fy to 0, I should be getting two equations, right? And on solving those two equations, I should be getting 2 by 3 and 1 by 3. So we have two equations now. Remember, we need to find three constants and we have two equations. Now, how will the third equation come? Because we need to find c also, right? For the third equation, we are already given that f of 2 by 3 comma 1 by 3 is minus 1 by 9. So this is our third equation. So using these three equations, we can find a, b and c. So now let us just find the first order partial derivative of with respect to x. So fx comma y was ax square y plus bxy plus 2xy square plus, so f of x would be, just treat y as a constant. So this would give me 2axy plus by plus 2y square, right? And c was a constant again, so 0. Equate this to 0. So this is our first equation. Now for f of y, treat x as a constant. So this would give me ax square plus bx plus 4, 2 and 2, 4. So 4xy, right? Into 4, it's 4xy equals to 0. So this is our second equation. And we know that our interior stationary point was 2 by 3 comma 1 by 3. So x comma y equals 2 by 3 comma 1 by 3 was our interior stationary point. This means that I'll be just using this and substituting 2 by 3 comma 1 by 3 in place of x and y respectively, and then I'll get my two equations. So let me just find this out. 2axy. So 2 by 3 into 1 by 3 is 2 by 9. 2 by 9 into 2 would be 4 by 9. 2 by 9, 4 by 9. So 4 by 9 a plus by. Now by. B was 1 by 3. Sorry, y was 1 by 3. So b into 1 by 3, b by 3. B by 3. Yes. Now 2y square. So we already know that y is 1 by 3. So 2 into the square of 1 by 3 would be 1 by 9, right? So 2 by 9. So 2 by equals to 0. So this is our first equation actually, or let me just write 3 in front of this, right? And for my second equation now, ax square, so this would give me 2 by 3, 4 by 9a again, 4 by 9a, 4 by 9a, plus b by 2b by 3, 2b by 3, because it is bx, plus 4xy, so again 4 into 2 by 9, 8 by 9, 8 by 9 equals to 0. This is my fourth equation, right? Upon solving this, I'll be getting 4 by 9a, or let me just write the third equation first. Wait, so now I can solve these two equations for a and b, because the term of c didn't arise in this, right? So I can just solve these two equations and find out a and b, right? So 4 by 9a plus b by 3 plus 2 by 9 is equal to 0, and 4 by 9a plus 2 by 3 2b by 3 plus 8 by 9 is equal to 0, right? So for this, what I'll be doing is 4 by 9a plus b by 3 is equal to minus 2 by 9, and 4 by 9a plus 2 by b by 3 is equal to minus 8 by 9, and I'll just subtract these two equations. I'll be getting this and this will get cancelled. I'll be getting minus b by 3 equals 8 minus 2, 6. 6 by 9, 3 and 3 gets cancelled, 3 cancels 2 away. I'll be getting b as minus 2. Now, similarly, I'll be putting this in the in the third equation, in this equation, which is actually the first equation. Transforming the first equation gives me the third equation. So I'll be utilizing this equation. So 4 by 9. Oh, wait a minute. Just zoom it here. So it will be 4 by 9 into a 4 by 9a 4 by 9a plus b by 3 plus b by 3 plus b by 3. So b was minus 2. So minus 2 by 3 uh, plus 2 by 9 is equal to 0. So 4 by 9a, and this would be 2 by 3 minus 2 by 9, which would be 4 by 9a equals by 9a equals, sorry, 4a by 9 equals 9. So this is 6 minus 2, 4, 4 by 9, and this would be, hmm, have I made some mistake? I don't think so. Hmm. So a turns out to be equal to 1. 9 and 9 gets cancelled, 4 and 4 gets cancelled. So a turns out to be equal to 1. A is 1 and b is minus 2. Let us check now. Mhm. So for the last equation, we know that. The last equation, we know that. Hmm. So for the last equation, I know that f of 2 by 3 comma 1 by 3 was minus 1 by 9, and my fx comma y was ax square y. Ax square y means that, again, ax square y. So 4 by 9 into 1 by 3, 4 by 27a. 4 by 27a plus bxy, and a was 1. So a was 1. Wait a minute. A was 1, right? So this was 1. So 4 by 27, right? And b was minus 2. Bxy. So x was 2 by 3. Y is 1 by 3. 2 by 9. 2 by 9. And b was minus 2. So minus 4 by 9. Minus 4 by 9. Yes. Hmm. Plus 2xy squared. So xy squared. So x is 2 by 3. 2 by 3 into 4 is 8 by 3. 8 by 3 into 1 by 9. 8 by 3 into 1 by 9 would be 8 by 27. 8 by 27. 8 by 27 plus c. And this should be equal to minus 1 by 9. Now solving this equation gives me the value of c. So 4 by 27 minus 4 by 9 plus 8 by 27. I'll just take 27 common as the LCM. So 27. Hmm, So this would be 4 by 27 minus 4 into 3 is 12. Minus 12 plus 8 by 27 would give me 8 only. Plus c. So wait a minute. Plus 1 by 9. Wait a minute. I'll just take 1 by 9 to the other side, the LHS, and this would become plus 3 and minus c. Right? I made some mistake. This was minus 1 by 9, right? Hmm. 4 and 3 is 12. 8 plus 4 is 12. 12 and 12 gets cancelled. 3 minus 1 by 3. I read out. I have made some mistake. So A was 1. A was 1, right? A was 1. B was minus 2. So 4 by 9. 4 into 4A plus B by 3. B by 3 was 2 by 9. Minus 2 by 3. And minus 2 by 9. So 2 by 3 minus 2 by 9. So 3 into 2 is 6. 6 minus 2, 4. A is 1. A is 1, yes. We are correct. Now 4 by 27. 4 by 27. A was 1. So 2 by 9. 2 by 3. So this give me 4 by 20 or 4 by 9. 4 by 9 to 1 by 3, 1 by 27, 4 by 27, yes. Plus v was minus 2. V was minus 2 into 2, minus 4 by 3 and 3, 9, minus 4 by 9. This is also correct. Plus 2xy square, 2 into 2 is 4. 4 into, so this is 4 by 27. This is actually 4 by 27, not 8 by 27. Right? This should be 4 by 27. So 2 into 2 is 4, and multiplied with 1 by 4 by 9, 4 by 3 into 1 by 9. This is 4 by 27. 4 by 27. Wait a minute. This should be 4 by 27. Right? This should be 4 by 27. 4 by 27. Right? Now solving this. This is what happens when you're trying to calculate. You've done all the steps correctly, but somehow or the other, if you make a small calculation error, you can lose out on marks. So 4 by 27. Now 4 into 3, 12, minus 12, uh, plus 4, plus 3, I guess. Yes. So 4 and 4, 8, minus 4. So this is minus 1 by 27, and minus C. So C turns out to be, yes, so this is correct. C turns out to be 1 by 27. So these are my values of A, B, and C. Let me just write it again. Right. So A turned out to be 1, B turns out to be 2, and C turns out to be 1. B turns out to be minus 2, and C turns out to be 1 upon 27. You can check the answer. I hope this should be correct. I hope this should be correct. But do check out the answer. Though I know I have already checked this answer again previously. I solved this question with you, so I already know the answer is correct. Yes. So now let's just solve part B now. So part B says that with the values of A, B, and C found in part A, find the maximum and minimum values of f over the domain in the xy plane determined by the inequalities x greater than equal to 0, y greater than equal to 0, and 2x plus y less than equal to 4. So part B says that with the values of A, B, and C found in part A, find the maximum and minimum values of f over the domain in the xy plane. So we need to find the maximum and the minimum values of f using or in the domain, specifically in the domain, we need to find the maximum, max or min values of f x comma y in the domain x greater than equal to 0, y greater than equal to 0, and 2x plus y less than or equal to 4. Right? So this is the domain given to me. I'll just zoom out a bit. Wait a minute. Let me just use it. Yes. So now we need to find the max or minimum values of f in the domain x greater than equal to 0, y greater than equal to 0, and 2x plus y less than equal to 4. You would be able to see what I'm going to write now. Hmm. Hmm. Now for this, we already have two equations. To find the maximum minimum values of fx comma y in the domain, we first need to find the interior stationary points, all of the interior stationary points. Then we need to check if these interior stationary points are lying in the domain or not. The domain that is specified to us, x greater than equal to 0, y greater than equal to 0, x plus y less than equal to 0. Then we need to check for the corner points, the boundary points, and we'll be using the extreme value theorem for that. Also, we would be creating a certain diagram to check all of the values, and then after comparing all of the values at those specific points that arise, including the interior stationary points and the boundary points, we conclude that whether uh, the values that we are getting is the max value, is the global max or the global min in that specified domain. Also, to solve this, I am going to create a diagram and then check on the different regions. I'm not going to use the Lagrange here. Why? Because I haven't discussed the Lagrange in my previous videos. So I don't want to just introduce it randomly. Though if you are better good at solving using Lagrange, I would recommend. I would highly recommend using that method, right? So the max or minimum values of fx comma y in the domain. So we already had the equations of fx and fy, right? So fx was, let me just copy this. So f of x was this, right? So this was my fx and fy. I'll be now just substituting the values of fx and fy, the values of a, b, and c, a and b in fx and fy. So fx turns out to be, so 2a, a was 1. So this becomes 2xy, 2xy plus b was minus 2, minus 2y plus 2y square. So 2y square, yes, 2y square will remain as it is. This is 0. And f of y would be, f of y would be ax square. So ax square, a is 1, so x square, and b was minus 2, minus 2. So minus 2x plus 4xy. X was, we don't know x, 4xy equals to 0, right? Now just taking common the values of x and y, x or y. So in the first equation, in this equation, which might be the fifth or sixth equation, let us just write this as sixth and seventh. Right. So in the sixth equation, I'll be taking y common. So just taking y common, I'll be left with 2x minus 2 plus 2y equals to 0. And in the second equation, I'll be taking x common. So x, and this will give me x minus 2 plus 4y equals to 0. So from these two equations, which is the 8th and the ninth, I'll be getting y equals to 0, or 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 this 2x minus 2 plus 2y is equal to 0. 2x minus 2 plus 2y equals to 0, which translates as 2x plus 2y equals to 2, which can be written as x plus y equals to 1, right? Which can be written as x plus y equal to 1, right? Now, I'll be using this equation. For this equation, I'm going to write x is equal to 0, or x minus 2 plus 4y equals to 0, which gives me which gives me x plus 4y equals to 2, right? Or this. So now, solving this equation, x plus y is equal to 1 and x plus 4y equals to 2. So x plus y equals to 1 and x plus 4y equals to 2. I would be getting, I'm just subtracting the two equations. So I'd be getting minus 3y equals minus 1, minus 3y equals minus 1. So y turns out to be equal to 1 by 3, positive 1 by 3. And similarly, x turns out to be equal to, if I just use the first equation, x turns out to be equal to 2 by 3. X is 2 by 3 and y is 1 by 3. So x is 2 by 3 and y is 1 by 3. Yes, so this is one of our stationary points, which was already given to us, right? So 2 by 3 and 1 by 3 was already given to us. Another stationary point was 0 comma 0. And the stationary point is 0 comma 0. Why? Let me just tell you. When the equation was y is equal to 0, Then if I just use this equation, if y is equal to 0, and I'll use this in the second equation now. So this was the two equation that was given to me. These two equations were given to me, right? These two equations were given to me. Hmm. These two equations were given to me, right? So according to these two equations, y is equal to 0, and when y is equal to 0, this implies that x into, now using the second equation, so x minus 2, now plus 4y would be 0, so x into x minus 2 is equal to 0. So x can be 0 or x can be 2. So one of another point that we have is 0 comma 0, and we have 0 comma 0, and we have 2 comma 0. Another point that we have is 2 comma 0. These are interior stationary points. And we can have some more points. Let me show you. Hmm. And we can have some more points. So when when uh, when now x is equal to 0, when x is equal to 0, when x is equal to 0, then x is equal to 0. Hmm. When x is equal to 0, y turns out to be, y can be, so x is 0, so this becomes the first equation. Using the first equation now, this gives me x is 0, so minus 2 plus 2y, minus 2 plus 2y equals to 0, right? Using the first equation now, using this equation now, right? So now I'll be getting y is equal to 0, or y is equal to 2y equals 2, so y is equal to 1. So the equation that we can have is again 0 comma 0 and 0 comma 1. So the kind of points that I'm getting is uh, let me just write all of the points here. So 2 by 3 comma 1 by 3, these are the stationary points. Now list of stationary points. Now let me just write them as I said. So stationary points, these are the set of stationary points are x comma y belongs to, just let me write this like this. So 2 by 3 comma 1 by 3, 2 by 3 comma 1 by, I was going to write x comma y belongs to R, but I didn't. Why? Because they don't belong to R. We have a specified domain, right, in the first quadrant essentially. So I can't write x comma y belongs to R, right? Um, 2 by 3 comma 1 by 3, 0 comma 0, 0 comma 2, no, 2 comma 0. This was 2 comma 0 and 0 comma 1 and 0 comma 1. This is my set of stationary points. 0 comma 1. Now I need to find the boundary conditions, boundary points, right? This is a big question. Find the boundary points. Hmm. Now the domain that was given to us was x. Just give me a second. Hmm. Yes. So now we are going to check the boundary points. The equations that are given to us is x greater than equal to 0, y greater than equal to 0, and equal to 0. and 2x plus y less than equal to 4. 2x plus y less than equal to 4, right? So this means that all of our points are lying in the first quadrant, right? Because x is positive and y is also positive. So this is the first quadrant, right? 2x plus y less than equal to 4. So x plus y less than equal to 4. This means that, let me draw a line for this. This is 0 comma 0. This point is 0 comma 0, and x 2x, right? So this can be x is 2. So 2x plus y equals to 4. 2x plus y equals to 4. So x is 2, y is 0. This is one of the points, and y is 4, x is 0. So these are the 2 points that I can have here. This is 4, right? So now I'll just join these 2 points with a ruler. Hmm. Hmm. So these are the 2 points. Yes. Hmm. So this is our region that we need to check. Let me just draw the diagram again now. Hmm. So this is my diagram. So we have now three regions. Three regions where we need to check, right? Three regions. So this is my first region. This would be my second region, and this is my third region. Now I have discussed how to use a diagram and solve for the boundary points in my previous videos. Essentially, in my initial videos, I have discussed this concept, right? So go and check that out. You'd be understanding what I'm doing. So three regions I've divided the diagram into, right? We need to check the boundary points. The interior points we have already taken care of, right? First, there was another point that we had, no, 2 by 3 comma 1 by 3. We need to check if this lies within this point or not. So this equation was 2x plus y less than equal to 4. So if I just substitute 2 by 3 comma 1 by 3, 2 by 3 plus 1 by 3, this turns out to be 4 by 3 plus 1 by 3, which is 5 by 3. 5 by 3 is less than equal to 4, yes. Less than equal to 4, yes. So 2 by 3 comma 1 by 3 also lies in the region. 2 by 3 comma 1 by 3 lies in the region, yes. Uh, and the other points that we had was this. These are the points that we had, right? 2 by 3 comma 1 by 3, yes, this lies. 0 comma 0 also lies. 2 comma 0, 2 into 2 is 4, 4 plus 0, yes, this point also lies. 0 comma 1, yes, this also lies. Hmm. These points lie in the region, yes. Now check the stationary points, right? 2x plus y less than equal to 4. This was the line that we had. Yes. So this region is, this region is, this region is, this first region is, this is where x is permanently 0, because these are all the points that lie on the y-axis. So first region, x is 0, y lies between 0 and 4, right? First region, x is 0 and y lies between 0 and 4. Second region is, this one. Here we have y0, x lies between 0 and 2, right? Third region, third region is, all of the points lying on 2x plus y equals to 4, right? Points lying points lying on 2x plus y equals to 4, right? Hmm. So now I'll be solving for the first region. X is 0 and y belongs to 0 and 4. The function that was given to us was after substituting the values. Wait a minute. Let me just copy this. After substituting the values, the function became. Wait a minute. I didn't write the function. Hmm. Yes. Hmm. So my function was fx comma y equals ax square y. Ax square a was 1, so x square y plus b was minus 2 xy plus 2xy square plus c was 1 upon 27. Yes, so this was my function. Now, if in the first region we had x is equal to 0 and y lies between 0 and 4. So I'll just substitute x being 0. So x is 0 here. So 0 comma y. So this function becomes a variable. This function becomes um, essentially in one variable, right? So 0 comma 0, 0 comma y becomes g of y, which is equal to 1 upon 27. 1 upon 27. Yes. So the function attains the value of 1 upon 27 in the region G in the region 1, right? So all the points lying here give me the same value, which is 1 upon 27. Now if I just take the second region where y is equal to 0 and x lies between 0 and 2, y is 0. So here if y is 0, this becomes h of x, which again becomes 1 upon 27. 1 upon 27. Yes, 1 upon 27. So all the points lying here in the second region give me the value 1 upon 27 again. Now the third region, all of the points lying on the line 2x plus y less than equal to 4. For this, we will have to solve. So the function given to me is this. Now we know that 2x plus y equals to 4 here. So y becomes 4 minus 2x. So I'll just substitute 4 minus 2x. So f of x comma 4 minus 2x, right? This was the equation, right? Yes. So 4 minus 2x, and this becomes x square 4 minus 2x minus 2x 4 minus 2x plus 2x 4 minus 2x whole square plus 1 upon 27, right? So this is my function now. Hmm. Yes, so I'll be utilizing this region. Yes. Hmm. So just paste this. I don't know why this is not moving. Yes, so this was my function, right? Hmm. Now I just solve this. This function again becomes a function in x only. So I'll be just denoting this function in m of x. This function becomes one variable function. This becomes mx. So mx is equal to 4x square minus 8 minus 2x cube 2x cube minus 8x plus 4x square plus 2x into now the whole square of 4 minus 2x. So whole square of 4 minus 2x is 16 plus 4x square plus 16 plus 4x square minus 2 into 4 is 8 into 16 minus 16x, right? Plus 1 upon 27 plus 1 upon 27, right? Now the first derivative of x would be function mx would be m dash x, and this would be equal to 8x minus 6x square minus 8 plus 8x 8x plus again 32 plus 8 into 4 into 8 8x cube 24x square minus 32 x square, so minus 64x. 2 into 16 is 32, 32x square, so minus 32x square, yes. So this becomes minus 64x plus 1 upon 27, this would be 0 because this is a constant, right? So I'd be equating this to 0. So 8 and 8x cancels with 64, so this gives me 16, 64 minus 16 will be 16 fours or 64, right? 48. 48. No, sorry, 36. Hmm. So now I'm left with 24x square minus 66x square. So this would be positive 18x square, and 8x and 8x is 16x. 16x 16 minus 64 is 54. 54 minus 8, right? No, 54 minus 6. So this would be 48. So 48. So 48 minus 48x minus 48x, and I'm left with the constant is 32 minus 8. 32 minus 8 is 24 plus 24 is equal to 0. So if I just take 8, 8, I can't take 8 common, I can take 2 common. If I just take 2 common, I'll be left with 9x square minus 24x plus 12. I can take 3 also common, wait a minute, so 6 is common now. So 3x square minus 8x plus 4, and this is equal to 0. Finally, yes. So 3x square minus 8x plus 4 is 0. So I've just solved this equation now. This is standard trying to find first derivative, then trying to find the critical points, then trying to find and distinguish which one is a local maximum or a global maximum, right? So for this, 3x square minus 8x plus 4, so 3 into 4 is 12, 12, 6 into 2 is 12, 6 into 2 is 12. So minus 6x minus 2x plus 4 is equal to 0, 6, and if I just take 3 common here, this would give me 3x common. So this will give me x minus 2 minus 2. I can take minus 2 common, so this will give me minus 2x minus 2, and this would be equal to 0. So this would give me 3x minus 2 and x minus 2 is equal to 0. This would give me x as 2 by 3 and x can be equal to 2. Now again y was 4 minus 2x, so y can be 4 minus 2 by 2 into 2 by 3 is 4 by 3, right? So 2 into 2 by 3 is 4 by 3, and this 3 into 4 is 12. 12 minus 4 is 8, 8 by 3, 8 by 3, and y can be 4 minus 2x, so 4 minus 2 into 2, y is equal to 4 minus 0, y is 0. So we have got ourselves another point, which is x is equal to 2 by 3. Oh, wait. So another set of points that we have is 2 by 3 comma 8 by 3, and we have 2 by 3 comma 8 by 3, and we have 2 comma 0 again. Oh, now we need to just check the value of the function at these different points, the interior points and these points, and then classify them as a global, local, maximum, and all that, right? So now let's check the value of 2 by 3 comma 8 by the value of the function at 2 by 3 comma 8 by 3, 2 by 3 comma 8 by 3, and this my function was, let me just copy my function. This was my function, right? Copy. Hmm. Yes. So now I have to just check the value of the function at 2 by 3 comma 8 by 3. F of 2 by 3 comma 8 by 3. And this would be x squared, so 2 by 3, so 4 by 9 into 8 by 3, 32 by 27, 32 by 27, 4 into 8 is 20, is 4 into 2 by 3 comma 8 by 3, yes. 32. Minus 2xy, x and y. 16, 16 by 16 into 2, 32, 32 by again 9. This is 9. 16 into 2, 30, 32 by 9. Plus 2xy square. X is 8 by is 2 by 3, so 64. 64 into 2 is 128. 128 into 2 is 256. So 256, 256 upon the square of 3 was 9. 9 into 3, 27. Plus 1 upon 27. So solving this will give me, let's take the, this as 27, 32, and 32 multiplied with 3 would give me 6 and 9, 96. 96 plus 256 plus 1. If I just calculate, I'll use the calculator now. Hmm. So 32, I'm just using a calculator right now. 32 minus 96 plus 256 plus 1. This is 193. 193 by 27. So this is f of 2 by 3 comma 8 by 3 is 193 by 27. And we need to check the value of the function at 2 comma 0. So this would be this would become 0 0 0 and 1 upon 27 again. 2 comma 0 is also 1 upon 27. And now the time comes to check the value of the function at the interior stationary points. So here also, if I just check the value, if I just check the value at different points, here we already know we were given that the function at 2 by 3 comma 1 by 3 becomes minus 1 by 9. This was given to us. f at 0 comma 0 becomes f at 0 comma 0 gives me 1 upon 27. F at 2 comma 0, f at 2 comma 0 gives me 1 upon 27. F at 0 comma 1 would again give me 1 upon 27. 1 upon 27. And at these and at the different regions also I showed you. At this region also, when we check the points at this region, at the first region also I'll be getting all of the points as 1 upon 27. The functional value would be in the first region, fx comma y would give me 1 upon 27 as the value. In the second region also the value would be 1 upon 27. I already showed you guys, right, in the second region also. And in the third region I showed you that the 2 points that were arising were 2 by 3 comma 8 by 3 and 2 comma 0 and 2 comma 0. And when we checked the value, it turned out to be 193 by 27, and at f2 comma 0 again turned out to be 1 upon 27, right? So finally we can say that, finally if I just want to conclude, I would be writing that the the max value the max value is at 2 by 3 comma 8 by 3, and f of 2 by 3 comma 8 by 3 is 193 by 27, and the min value is uh, min value is at 2 by 3 comma 1 by 3. 2 by 3 comma 1 by 3 was the point, right? Yes. And the min value is at 2 by 3 comma 1 by 3, and the value is min value is at 2 by 3 comma 1 by 3, and the value is 2 by at the function value at 2 by 3 comma 1 by 3 is minus 1 upon. You can check that out too, right? So this was my new video on optimization. This was a very long video. I was myself tired when I was solving this whole question. This was quite big, but it would help you a lot when you match the solutions. I hope this matches. I actually know that it will match. But yeah, the main point of creating all of these videos is that you guys, after studying the concepts, when you sit and solve the questions, you would know what are the answers and what is the method to solve these questions, right? It's really helpful. Otherwise, if you just pick up a solution manual, then you would just directly find the solutions to these questions and no one explaining them how to solve the questions, right? So yeah, thank you. If you like the video, please like, share and subscribe the channel and put in a comment. It encourages me to keep putting on more videos. Thanks. Bye bye.